In computer science, there's a field that combines linguistics and computers, and we call it natural language processing, or also known as NLP. Natural language processing allows machines to break down and comprehend human language. It's at the heart of the software we use every day, from translation tools, chatbots, spam filters, and search engines to grammar correction systems, voice assistants, and social media monitoring programs. In almost all natural language processing projects, stemming is one of the most common data pre-processing operations we do. It is a fundamental natural language processing approach for fast and accurate information retrieval. Stemming is a technique used to extract the root or base form of the words by removing affixes from them. Let's take a look at an example for search engine. Search engines use the keywords in the text to generate relevant search results. To that goal, Google has been optimizing the search engine using various stemming techniques since 2004. These modifications to the search algorithm allow search queries to be distinguished and hence evaluate full phrases considerably more precisely. The stemming algorithm recognizes words based on their grammatical stem. As a result, the search engine identifies a link between word variations and provides relevance to this page. For example, if you search for searching for something, you'll obtain searching, searched, and search results. Furthermore, stemming minimizes the amount of storage space necessary, which speeds up the search. Stemming not only lowers the text to its most basic forms, but it also optimizes comparable phrases that match to the primary keyword's topic area. This is utilized not just in search engines, but also in other natural language processing applications such as machine translation, document summarization, text categorization, and morphological analyzer. Stemmers or stemming algorithms for our language, Waray, do not yet exist. So in its absence, we developed Wing or the Waray stemming algorithm. With this, we can provide and build a stepping stone for other natural language processing tools for our language. Waray, or simply Waray, is spoken by approximately 2.5 million native speakers throughout most of Samar Island, the northern and eastern portions of Leyte Island, and the eastern portion of Biliran Island in the Philippines. Waray language uses affixes added to the root or stem to form a new word. These include prefixes, infixes, and suffixes. Another way of forming Waray word is through reduplication, the repetition of certain syllables of a root or of the root, the partial and full reduplication. The Wing algorithm was created using this. The technique employs the affix stripping approach, which is used by other stemming algorithms such as Lovins and Porter. It also used the idea of a pattern or string search algorithm which searches a string inside a string. With this, a list of affixes from various sources was compiled, along with the corresponding rules, and then the 10 steps of the stemming algorithm was made. Step 1. Get the word. Step 2. If the length of the word is even, and its first half is the same with the second half, remove the second half of the word, then go to step 8. Step 3. Else if the length of word is odd or if it is even but its first and second half are not the same, go to step 4, else go to step 7. Step 4 is about prefix removal. The prefix is removed if the rules of that prefix are met by the word. Step 5 is about infix removal. The infix is also removed if the rules of that infix are met by the word. Step 6 intends to remove partial reduplication if the word's first syllable is repeated. Step 7. If the word commits no modification, go to step 8. Else, if it commits modification, go to step 2. Step 8 is about suffix removal. The suffix is removed if the rules of that suffix are met by the word. Step 9. If word commits no modification, go to step 10. Else, if it commits modification, go to step 8. Step 10. Return word as the output. This algorithm was implemented through Python programming language. (4,011) of Waray words were taken from various Waray literature materials that contains Waray language in which were stemmed through the implemented algorithm. Word duplications were identified and the number of distinct words was calculated, resulting in a total of 1,958 unique words. Each word was subsequently stemmed, gaining a total of 1,220 stemmed words. This 1,220 stemmed words was assessed by Waray literate individuals to determine if the stemmed words are correct, in which accumulated a total of 831 correct stems. Using the performance metric, word stem factor or WSF, it gained 62.31%. It surpasses the minimum threshold for this factor, which is 50%. This indicates that wing algorithm can stem Waray words. For the correctly stemmed words factor or CSWF, it attained 68.11%. This indicates that wing algorithm's accuracy passed and exceeds the expected minimum threshold for this factor, which is 50%. Based on the analysis carried out for this study and the results obtained, the following conclusions are presented. The development of wing algorithm was able to adhere to the intended objective of the study. The results obtained shows that the algorithm stems the words with an accuracy of 68.11%. The 62.31% word stem factor indicates that Waray literatures uses more affixed words than those already on the base forms. Words that the algorithm incorrectly stemmed are due to the unnecessary removal of suffix and also due to the enlisted affixes. Other stemming errors were a result of the morphological complexity of the language. Based on the findings of this study, the researchers recommend that the wing algorithm be used in natural language processing tools for the language to assess its effect on these tools. More affixes and further analysis on the removal of suffixes are suggested for future studies and improvements to the algorithm. Finally, it would be interesting to test other stemming techniques and see how it performs on Waray language. As we emerge in the modern world, this could be a way of preserving our local language, Waray. This will be the end of this presentation. Thank you for watching.